ask all the other presenters to come up to the stage and also be joined by Andre Ristaino from ISA. Have a seat. I've got a bunch of questions, and I'm sure there's some questions in the audience. I should mention, maybe Andre can talk about the project that Louis presented was an award recipient from ISA, and that's why Andre is here. So maybe you start with that. Andre, can you tell us just a little bit about the award and how you selected Louis' project for that?
Right. So I run the consortiums at ISA, and the ISA 100 Wireless Compliance Institute promotes that standard and does the certification testing and just manages that ecosystem. But each year we look for something that's notable, either a novel application of the technology or a company or a researcher that's done some formalized, structured analysis of the technology and its performance and published that, or something that's new. So the ISA 100 wireless standard was it was completed about 10 years ago, but one of the key features of it was that it was designed to be very scalable on a single level. And that was the design, but we didn't know if it really worked. And so we knew that over time that there would be a deployment that's pretty scaled up. And so this is the first one that I've seen that's a large-scale deployment of a large sensor network that's wireless with ISA 100. And it works. And these companies were willing to publish their success story and describe what they did and the value from it. So for that reason, they earned the award this year.
Okay. I'm going to start with one of my own questions. Excuse me for starting with my own question, but I can't resist. You all mentioned security a little bit. Louis, you alluded to it. You have different use cases. I think utility T&D infrastructure is kind of critical infrastructure. Pipeline infrastructure is critical infrastructure, and you were talking, Louis, about safety applications mixed in with your energy saving applications. So I wonder if you two folks, Stuart and Mo, can talk about what governed your cybersecurity, what regulations kind of you were shooting for in cybersecurity, and how you maintained compliance with those in these projects. I think I know the answer for Duke, but I'm not sure. And then Louis, if you could talk about the mixing of safety applications with energy applications. Energy application, if it fails, you lose money. But if safety application is a little different. So those questions came up into my mind. I wonder if you all could comment on those. Maybe Stuart, you want to go first, talking about the regulations that were driving you in those projects?
Yeah, so in the utility industry, I mean, the major standard today that is really focused on cybersecurity is the NERC CIP requirement, but that's generally for like the wholesale market. So typically stops at the transmission substations. But when you go at smaller loads, talk about the size of a distribution circuit, typically less than 10 megawatts, there really isn't any standards. We're trying to help drive those standards in the interoperability piece by requiring transport layer security at a bare minimum. So what that essentially requires is some type of identity in the end devices. When we first started doing our first smart grid deployments, we had very capable multifunctional devices that had communications. They had memory, they had storage. They had storage, they had a lot of capabilities, but unfortunately, because the apps weren't secure, because we couldn't really authenticate to the devices, we couldn't trust the devices because we didn't have that chain of trust. the putting controls in the field was really not approved within our operations. So it wasn't until these newer standards that pretty much build in transport layer security allow devices to be able to authenticate, as well as other ways of securing applications with containers and virtual machines. That's really enabling us to be able to run edge intelligence.
Okay, but you're saying in effect, because your utility or your installations have small modularity, all these DERs have relatively small modularity, that they get away easier on the NERC SIP.
So most of the solar today is not integrated into our operational systems.
Okay.
So we don't even talk to them. We don't even use their, we don't use the solar production that we buy back.
Okay. Mo and, well,
So
yeah.
I'll let Jared start with the regulations.
I don't know who was in charge of
Yeah.
regulatory compliance there. Was it Mo or Jared? Obviously, you both had to be. So
Jared would be the driver of it. We would be the technical resource to make it happen.
Yeah.
can you talk a little bit about the thinking that went on in that project there with
So-
regard to that?
Yeah, it's a DOT pipeline, so DOT regulated PHMSA explicitly. PHMSA has API 1164 recommended practice. So basically, what it spells out is, hey, this is you need to have a cybersecurity plan. So that's one step one there, and then basically it gives you recommendations on create a living document and follow these kind of standard protocols, access, all just kind of your normal stuff. Unfortunately, really in the regulation area, it's more like it's not API 1164 you must do it, it's the recommended practice, right? So basically you take those recommended practices, you try to implement them as best as you can. Of course, ICS, CERT, all that stuff, you kind of at some point kind of reach out to them, say, hey, can you take a look, do an audit on our system? And then of course they're more than willing to come in and tell you how wrong you are and all that stuff. So, but no, basically you follow that. That's what we followed as PHMSA recommended practice 1165.
Okay, Louis, I don't know anything about the regulation or mixing of those kind of applications in any sense in the downstream oil and gas industry, or specifically with ISA 100. Can you tell us a little bit about what constrained you, or what?
First of all, I have to say that we are not using this sensor for control, only for indication, okay? And we have our original wireless wired gas detector system of our plant.
Okay.
This, the wireless network allow us to, as soon as we identify a new risk, like for example, a machine that is leaking but cannot be stopped in the next 2 days, just we take a sensor and we put really close, as simple as that.
Mm-hmm.
And because traditionally what you did is you call somebody from operations, go 3 times per shift and measure if it's leaking or not.
Okay, so it's a supplemental
Exactly.
sensing.
It's another layer that we add.
All right. And now I'll open it up to the floor if there are questions. If somebody has a question, I'm looking for a hand. Okay, I've got more, so I'm kind of interested in asking another one, so I'll go ahead. This one is for Mo and Jared. You talked about designing your system for maintenance and allowing maintenance without losing data, and I assume that was at the lowest levels of the system too. So can you talk about what your design basis was? What were you? What length of outage were you designing for to avoid data loss, and how did you figure that out and figure out that was okay?
Yeah, so we started with, I talked with ARB and said, what downtimes can you have in the field? What is the regulatory PHMSA for how long can you be out? And Jared defined that, within X amount of minutes, you have to report the outage, and then you have to report after those amount of minutes, how long you've been down, and then, that it requires an inspection. You got to roll a truck, that sort of thing. And then we went to the top level, the middle tier layer of, okay, If we lose the distributors, the MQT distributors, then we have to stop and think about how long those devices can be stored in forward mode with memory, right? So how much can you store, right? So that helped us select the right devices, add SD cards to them, and get the additional storage. And then we went to the top layer and said, okay, alarming, ARB was really big on making sure they met the PHMSA requirements. They had the documented alarming systems. So if you had a leak detection, if you had some sort of seal fail or something on a pump, you didn't want to lose that, because if you didn't report it within a certain amount of time, that could be a violation. So when we thought about redundancy, we thought about all those layers, right? And so that kind of gave us a guideline to fall back on. We don't want these field devices to be down for more than 5 minutes. We don't want this to happen. We don't want this to happen. And that's kind of how we scale the redundancy. Is we would do time studies, and it was kind of phenomenal, because we had the Cirrus Link transmission module. We were trying to time study and test it, and we were like, okay, we're going to shut down distributor 1 and see how long it fails over. And then we were shutting down distributor 1, and we're like, well, wait a minute, why are they on distributor 2? Right? Because they'd moved over before we kind of really had time to study the analysis of it. So we're like, well, that's awesome, right? They just natively did its job, right? And it was the same thing with the redundancy side, the gateways. We had really good success with that. And then the last layer of redundancy was the device itself, right? So we needed to pick devices, and we were talking about the Debian platforms and stuff before, similar to what when he was talking about having the edge devices running Docker images and stuff. We had to design it in a way that they could. We knew we tested it by just power failures and disruption of power failures. So disrupt the power up and disrupt the boot and the BIOS, and just making sure it would recover right. So those were kind of the thoughts that we had. We took the customer's regulatory recommendations and said, how do we test redundancy at each level? And then how do we design for that? And that's kind of where we ended up with our design.
Okay. A question I have for Stuart, and kind of you could expand on a little bit. One thing I've heard from utilities acquiring distributed energy resources is a lot of times they come with existing ICS infrastructure, and that is, I've heard that's a problem for utilities. And also you mentioned specifically, obviously you've got a lot of, I don't say necessarily legacy, but you've got a lot of SCADA infrastructure that was designed for the one-way power system that is eventually going to go away. So can you talk about managing the installed base or the legacy systems, both at the distributed energy resources and at the SCADA system, and kind of what your strategy is for that?
Okay. Yeah, so we'll start with kind of the customer side, solar inverters. Like, you hit it right on the spot. There really is no security in their programmable logic controllers. And a lot of them speak Modbus. It's kind of like the SunSpec Alliance chosen protocol. In many cases, serial Modbus. And so effectively, these assets don't have any identity, and we really can't even trust what's even on the network on the south side of, for example, our communication device. So, for example, we'd put some type of communication node in front of that solar to retrofit it. And we would have a variety of different measures to try to reduce the risk. Effectively, you're going to need to add what you would call like a data diode. You would have to make sure that the traffic that comes out of the device is restricted really to just the adapter. So your translator.
I've heard other utilities say, well, yeah, when we acquire the asset, now we just rip and replace. Have you guys thought about doing that, or is it just?
No. So most of the solar sites that we're looking at are 5 or 10 megawatts. So it's in many cases, we may not even own the asset. So we're not allowed to really touch a customer system. Mm-hmm. But we can, for an interconnection, we can require some type of communications and integration to our control system. So as I mentioned, kind of having a utility-owned communication device is the way we can monitor at least that asset. And then kind of going to the grid side, kind of the traditional protection and control devices that are on utility infrastructure, like the distribution system. We'd also add a communication device, but we can do a lot more behind on the node on the southbound side, such as adding time synchronization. We can add essentially certificate or PKI in the node itself. We can whitelist the information coming out of the device so that only the stuff that gets shared on the wide area network is what's defined in our data model. And then containerizing pretty much every application for resilience. So if, for example, if you have a Docker container and for some reason it's failing, you have container orchestration that can see that and immediately, spin up another container and fail over. And so that from an operator perspective, we don't even see any hiccups. And so, and then the last piece is, we will lose comms. We will lose communication. So how do we have intelligence that can store data and effectively cache the latest state and while it's local, and so the device can still operate and do its job until it gets back on the network.
Okay. What about the back end or the tertiary SCADA systems? Any adjustments in those so far for this?
So the goal is really to operate your distributed resources as well as the other grid edge technologies at a much finer resolution, so that the control constraints provided by distribution management system are typically in 5 to 15-minute intervals.
Okay.
And then we would have these decisions made in seconds, and effectively managed within boundaries.
Okay. All right. Any other questions? Because I've got a couple. Oh, there's one in the back.
Hi, kind of a two-part question. So you've talked about containers and those type edge things. Can you speak about how you're managing the security on those? How are you applying patches? How frequently? Security risk? How are you managing credentials on those? And then at least for the INS folks, you talked about AWS. How are you managing credentials up to the RDS? I think you said RDS database. So you use an IAM users, IAM roles. Can you speak to what the security model looks like some there?
Do you want to do the containers first?
Yeah, so I mean, as I mentioned, the architecture is assuming that we leverage some of the cloud native technologies. So, for example, a lot of the plumbing that we're expecting running these edge devices would come from an on-prem version of a cloud platform, where they would have let's just say a Kubernetes or kubelet type of agent, and they would have some type of security enclave that effectively acts like a key storage or key vault, which effectively manage certificates between containers as well as between end devices. But it's still in development. It's not really that mature. So I think right now a lot of what we see is in a heavier footprint. So we're really trying to work with them to kind of slim it down so it can fit into an edge device.
So that, with the certificates, that's authentication more, but do you have a strategy for applying security updates? Do you roll out new containers and destroy the old ones? And what's that CI/CD model look like? Any kind of detail that you can fill in there?
I mean, essentially, the platforms we're using are kind of have a configuration as code or configuration as infrastructure type of DevOps, cycle, and that's all built into that platform. And so, really, that's infrastructure that we're just gonna kind of procure. But yeah, to your point, that whole governance process, still needs work. And I think, right now the devices don't have anything, any identity, any security. So just adding the ability to even have certificates is a major step forward, because we can now at least authenticate with TLS between applications as well as between devices. But to your point, PKI is a big gap, and I think that hopefully there's a lot of opportunity in the space for folks to kind of innovate.
Yeah, so on the AWS side, specifically on the RDS question, IAM users with specifically administration rights to be able to access and change anything on the RDS instance. And then we're using the internal VPS network, the virtual private cloud VPC network. We only access it through either SQL authentication directly within that network. So what we do is we restrict the IP ranges of anything that can hit that based off the application servers, and then we put all the controls and security model for saying SQL users, and then you have to go in through like Studio Manager and say, okay, this user can authenticate, and by the way, you can only authenticate from this IP address in the VPC network. So IAM users to be able to do any administration of the RDS instance, and then and backup controls, And then we're doing the VPC network internally for our IP restrictions. And then we do the SQL authentication at that point for those users coming off those IP addresses. On the edge, if we're not doing a container-based operation, then we're doing patch updates to the operating system. INS took the approach of knowing that long-term we were going to have to pull down upgrades for ignition, or we were going to have to bring down upgrades for the operating system. So we built out a GitHub repo type server atmosphere hosted in AWS, where we could go in, like the code as a service, we would go in and make the modifications there, vet them in the lab and make sure that they worked, and that when we changed it, we didn't lose configuration, didn't lose data, and then we would architect that to where we scripted on the edge units the ability for it to periodically go to the database and go to the cloud and say, did I have something that's in the database that's requiring an update? If it did, it would bring that in over the SSL encrypted network and say, okay, execute, and it would just run that command, hit the repo servers across the SSL, bring down the package, inflate it, and reboot. And then we would just put that into a scheduled routine to make sure that we weren't doing it without the control center knowing what we were doing, and when can we take this site down? When can we do this kind of thing, right? There is some overhead in that, but we found that was the easiest way to be able to get the updates done. And it was a good way for us to test it, run it through the ringer, across a WAN, cellular and that sort of thing in the lab, and then say, okay, we know that's going to be successful when it hits the edge unit.
So for the IAM users, do you mind answering how often you rotate the keys, and you found a way to automate that, or is it manual?
Every 3 months. So we automated it with the Lambda services, and same thing with our certs. So the certs that we do for the network management side of things, we do every 3 months, and then the IAM users, we will typically go in and manually do that every 3 months. But there's a new test that we're running right now with the Lambda services in AWS that can allow you to swap the keys on that. But we're treading on that lightly to make sure, because once you screw that up, you're out of the box, right? You're out of that infrastructure. And the AWS guys, if you're paying for support, will help you get that stuff fixed, but they're very selective about how they will help you with the IAM users. So the Lambda services internally is one of the ways we're looking at doing that.
Thank you.
Sure.
Okay, question I have for Louis. You have implemented, you said, a turnkey contract that's really performance-based.
Yes.
So obviously, if your contract is performance-based, then your contractor needs access to the facilities maybe. Can you talk about what rules or whatever you have for letting the contractor have access to your facilities, what the protocols you use are, and what is the term of the contract? How long is the contract running?
The contract, I think, we started 5 years contract, what is one of the benefits is that instead of bringing a lot of people and making audits that takes weeks, there are just a few contractors that are identified as workers,
Okay.
and they come anytime during the day. As they have everything is processed. The feedback that we have from the system is this sensor and this sensor and this sensor is 5 degrees higher, 5 degrees less. So everything is very, very clear. So they just they work also for other companies. When they come to our company, they know where they have to go, and with some rules, they know how much they have to adjust. And they don't spend more time. They go inside, they adjust, and they leave.
Okay. So what you've done is you've taken a job that would normally be done in a turnaround with a lot of contractors and spread it out,
Yes, every day.
fixing things as they break, if you will.
Yes.
Okay.
And we let the contractor to optimize when it's best for them to do that job. Always with the bonus malus of the 0.5%. So we let them optimize their human resources.
Okay. Any other questions from the floor? Okay, well, I could ask questions for a couple hours, but I'd rather have drinks and ask questions. So I think we should give a round of applause to these folks. They certainly gave us our money's worth today, so thanks very much.